In the last class guys, we had discussed some problems on vertical circular motion. Okay, and I had told you that I am going to cover in the next lecture is what? The rotating frame and the fictitious forces. So basically guys, now we are at the verge of what? Just ending this chapter. Okay, and we have to cover in the this lecture as well as maybe few more lectures we need is what guys? The first thing that I am going to cover is what? Is calculating acceleration acceleration of a particle doing motion on a general curve. Okay guys, so first we have to understand the acceleration, that how and what are the components of an acceleration we can see of a particle when it is moving on a general curve. Okay, so that we are going to derive guys, then there only we will understand the idea of rotating frame. Okay, the idea of what? Rotating frame, which is basically is what? An non-inertial frame. Okay, why, how, all those things we will see at that point of time only. Today in this lecture only we will cover that. And then guys, I think we have to go into the next lecture after that to understand what, because we are, let's say, if we want to apply the Newton's second law in this rotating frame, which is a non-inertial frame, we need what? We need some pseudo forces. Okay, so guys, which are the pseudo forces we need in the rotating frame? Okay, so fictitious fictitious forces or pseudo forces for a rotating frame, for a rotating frame that is basically guys what? There is a three types of centrifugal, like three types of guys what? Pseudo forces we are going to encounter in this. Okay, that is what? Centrifugal force, Euler force, and guys Coriolis force. Okay, Coriolis force or Coriolis force. You can see that pronunciation and everything. So guys, this is the content that we are going to cover, and of course after learning all this stuff we will see a lot of problems on that maybe in the few more lectures. Okay, so guys, this way we are going to complete our circular motion chapter. So in a very detailed fashion guys, I'm covering this whole chapter so that in and out everything you should know. So acceleration guys, I could have discussed in the beginning, but I didn't discuss this thing in the start because otherwise like the you guys people may get what? Demotivated at that point of time. Now you have a like made a certain base of what? The idea of circular motion. So I think now you can understand the all these things in a much better way. Okay, so that's why guys, I'm going to cover these things from right now. So guys, before I begin, one thing I want to make very clear, that guys, here I am going to discuss everything in the form of what? Polar coordinate system. Okay, so if you haven't watched the starting lectures, one or two lectures of the circular motion, please go and watch those lectures, because without that idea, without those basics, you will not be able to understand the things that I'm going to discuss here. Okay, so it's highly advisable that go and watch those videos, the first second lectures, and then come back, and then guys you can continue from here. Okay, so without any further ado guys, I'll start. Okay, so see, the thing is, suppose if you are having a if you are having a let's say this is your y axis and this is your what? X axis, and let's say guys, this is some sort of curve on which a particle is going to move. So right now guys, let's say this is its position vector, 1 minute guys. Okay, let's say guys, this is its position vector r right now. Okay, and if it will move guys on this, let's say right now the velocity is what, in this direction v. After certain time guys, it will reach, let's say here. So the velocity will be what guys, it will be like this way, let's say v dash right now. And guys, this is your what, this is, you can say, your new position vector, that is what, r dash. Okay, r dash. So here guys, if you see, there are two things which are happening. First thing is guys, what, if you see that the length of the position vector is what, is changing. Okay, the length of the position vector is what is changing. That is the first thing is happening. It means the magnitude of r is going to change. Okay, second thing is guys, what, if you see the orientation of r vector is also changing guys. Okay, means earlier it was in this direction radially, in this direction, but guys now it is what, in this direction radially. Okay, so it means what, the vector uh, r is also changing its what, direction. So guys, there are two different types of component of the velocity would be present here. Okay, what, try to understand first qualitatively, then we will go in the math guys. So here there would be guys one component, 1 minute guys. There would be what guys, there would be one component that you are having in this direction of the velocity, which is helping you to what, to enlarge the what, the length of the position vector. Okay, and guys, there would be some component along this guys, which is perpendicular to the position vector, which will be what guys, helping to rotate the what, the position vector. Okay, so guys, when we are going to analyze the rate of change of position vector, we are going to see what, we are going to see there are two components. One is what guys, one is going to be along the radial direction, means r cap direction, and one is going to be what guys, in the theta cap direction or minus theta cap direction. Okay, so that is going to be the case guys, so keep this thing in mind. Okay, so guys, if you see, let's say right now this is the position guys, this is theta and this is what is theta cap. Okay, so we are going from very fundamentals with so guys, learn everything step by step, note down everything. Okay, and then only you will be able to understand what is going on here. So guys, see, so r vector, let's say at right now is what, this. And guys, what we are interested in right now, first to find out v. So v is guys nothing but what, dr by dt. Okay, so guys, I am going to represent this with the Newton way of representing. Okay, that is what, r vector dot. Okay, so it means what guys, it is a dr by dt basically. Okay, because there are a lot of expressions we are going to see in the in this whole analysis. So guys, multiple times writing d by dt will look very cumbersome, so that's why guys, I'm using this representation that given by what, Newton. Okay, that what, make the quantity and put a dot on the top. So this dot basically guys shows that how many times you are differentiating the function. Okay, so guys, one dot means what, single differentiation, double dot means what, double differentiation. Okay, so I hope you guys may be knowing this thing. Okay, so I'm going to use this representation guys for this further analysis. Okay, so keep this thing in mind guys. So what I will write guys here, if you see, the thing is, if we see that v vector guys, it is what, it is nothing but what we can say guys, r vector is nothing but what, r magnitude into what, r cap. Okay, r magnitude into what, r cap. So guys, because here r magnitude is also changing and r cap is also changing its direction, so that's why guys, r cap is also what, changing. Okay, so there are two vectors, sorry, there are two variables which are what, time dependent, which are changing with the time. So guys, we have to apply what, product function if we want to do it. Okay, so guys, this whole thing dot we have to run. Okay guys. Okay, so what I can write here, if you see, so v cap, sorry, v vector will be what guys, it will be mod r dot into r cap plus r cap dot into mod r guys. Okay, so if you see guys here, if you remember from the polar coordinate guys, in the beginning lectures, what I had told you, that guys, dr cap by dt is equal to what, omega into theta cap, and guys, d theta cap by dt is equal to what, minus omega r cap. Okay, so these two results guys directly I'm using here. Okay, to write the result. So guys, v vector can be written as what guys, this into r cap plus what guys, r cap dot can be represented as guys what, r cap dot means what guys, this only. So this can be converted into what guys, omega into theta cap. So what I can say guys here, what I can write here, r omega theta cap. Okay guys, so this is the value that we have gotten guys. So v vector basically will be what guys, we have discussed this thing. It is what guys, omega cross r, which is coming from here. Okay, omega cross r plus what guys, plus this r cap. Okay, so this is actually guys what, this is the velocity which is helping you to what, change the direction, to change the direction of position vector. Okay, and this component guys is changing the, this is helping to change the length of position vector, length of position vector. Basically guys, it decides as that guys, this component decides that how far and how closer with the time the particle is coming towards the origin. Okay, how far or how closer the particle is coming towards the origin, that is guys what is decided by this component. And this is what guys, how the position vector is what guys, rotating about the origin, that is guys what is decided by this equation component guys. So this is what v vector guys for a general curve motion guys. But we are not interested in v guys, we are interested in what, we are interested in a acceleration guys. Okay, so from now onwards guys, I'm not going to write r mod, I'm just going to write guys what, r only. R means guys, if I'm not putting any arrow or anything, it means I'm just talking about the magnitude. Okay, so guys, now I'm going to write this v guys as what, v vector as r dot r cap plus what guys, omega r theta cap. Okay, so you, if guys I'm not writing any mod here or arrow here, it means what guys, it is actually a mod only guys, means magnitude only. Okay, so guys, you keep this thing in mind. Now guys, if you see here, now we are interested in acceleration guys. So acceleration is what guys, it is nothing but what, v vector dot. Okay, so guys, here if you see, I have to find out the d by dt of this plus what guys, d by dt of r dot r cap. I'm just writing once guys what, to just show you that what we are going to do. Okay guys, so d by dt of omega r theta cap and r dot and r cap guys. Okay, now guys, if you see, omega might change okay with the time. So guys, as we have know that d omega by dt is what, alpha, so that is also possible to change guys. R guys can change. Okay, r guys can change. Okay, so we know that r is changing, the magnitude is changing guys, so that is also variable. Theta cap is also guys changing. So all these three guys are what, all these three are what guys, a variable in this product. Okay, and guys, here these both are also what, variable. So guys, when we have to differentiate this guys, what we can do, we can take 2 as a single function and differentiate 1, and then we can apply the product function again on this as we do in general. Okay, so we will apply that thing guys, and we will differentiate all of them, and then we will see that where we are heading. Okay, so guys, let me do that. Okay, so please pay attention guys here, what I'm going to do now. Okay, so guys, if you see, the vector a will be equal to what guys, so omega dot r theta cap plus what guys, you can say like this way, omega r dot theta cap plus what guys, see, omega I have differentiated guys, and I have multiplied this. Okay, and then guys, what I did, I put this here, this thing guys, I am further differentiating. So omega r dot theta cap plus guys what, omega r theta cap. Okay, dot. Okay, this is the thing guys. So there are three terms we are getting. This is what guys, this is product function where omega we are treating as a what guys, you can say a constant. Okay, and then we are just differentiating these two. Okay, and then we are differentiating here omega as a separate function and taking this as a what, another function. And then omega guys we have put it like this way. Let me put it like this way guys. Okay, so I think that would be easier. Just a minute guys. Okay, I'll make it easier for you. Maybe you get confused here. So what I'll do guys, see listen guys, what I'm going to do here, you treat guys what, this as a one function and this as a guys what, another function. Okay, so what we do guys, first we differentiate one function and then we multiply the second function. Then we guys what, differentiate the second function. Okay, when first we guys what, first we differentiate function, first function multiply the second function, then guys we differentiate the second function and then multiply the first function. Okay, this we are going to do guys. Okay, so that you can remember this thing. Okay, don't get confused. We are going to understand everything from very basic. Okay, so guys, first thing is omega dot, okay, omega dot multiply guys what, r theta cap, plus now guys what, we will put omega as a second function and differentiate this r theta cap guys as a function. So it will become what guys, it will become r dot theta cap plus r theta cap dot. Okay, plus guys what here, this is now we are moving on this guys. Okay, we are moving on this. So it will become what guys, it will become r double dot r cap plus what guys, r cap dot into r dot. Okay, this is the thing guys that we got it. Okay, so now if you see guys, see it is looking little clumsy guys, but this is the thing. If you are preparing for advance, okay, you have to like see all these things, like these are some beautiful things that are happening on this screen right now. Okay, then only you can learn, you can enjoy. Okay, there is no other way around, because the things are like this way only. If you are like literally want to learn everything, you have to be change your, you have to change your attitude, okay, towards the learning. Then only you can learn the stuff. Okay, otherwise you will always keep run away from the from the actual stuff. Okay, so guys here if you see what I'm going to do now, so a vector guys I can write as, guys see, uh d omega, d omega by dt is what guys, d omega by dt is what guys, that is alpha. You know that guys, that is what, alpha. So guys what we can write here, it is alpha r theta cap. Okay, plus guys here if you see omega r dot, okay, r dot, and guys theta cap is theta cap only. So let it put it like this way guys, theta cap. Okay, 1 minute guys. mm, Omega r dot theta cap plus guys what, omega r theta cap dot is what guys, it is nothing but what, minus omega r cap. Okay, plus what guys, r double dot r cap plus r dot cap is what guys, r dot cap is we know that that is what, minus, sorry guys, yes, r dot cap is what, omega theta cap. Okay, so omega theta cap r dot. Okay, so guys if I just combine all those things, is what I'm going to do, I'm going to separate the r cap functions separately and theta caps separately guys. So if I do that thing guys, what I'll get minus omega square r r cap plus r double dot r cap guys, this is one thing, plus what guys we got, omega r dot theta cap plus alpha r theta cap plus omega r dot theta cap guys. Okay, these are the things guys we have gotten here. So if you see guys what I have written now, a vector will be minus omega square r plus r dot r cap plus guys, here what we got, here we got uh I think, guys, just let me see once. Okay, so what are the remaining things, guys? One is alpha r. Okay, alpha r, and guys this and this is what, twice, so 2 omega r dot, guys, theta cap. Okay guys, so this is the acceleration term, guys, that we have found. Okay, now guys, what I'm going to advise you is I'm going to convert this acceleration thing in a form of what, vector. Okay, in a form of what, vector. And it's highly advised, guys, that you should remember that vector form for the solving the problems of what, circular motion and the rigid body dynamics, guys. Okay, because the concept that I am teaching right now is going to be needed, what, guys, there also. Okay, so that's why, guys, I'm highly advising that whatever I'm going to write down next, you should keep this thing in your mind. Okay, so guys, a vector, finally, guys, it will become what, it will be, guys, this, guys, omega square r minus omega square r cap can be written as, guys, what, omega vector cross omega cross r, guys. Okay, you can check also if you want to do it, guys. Okay, that is the first thing. Okay, plus, guys, what, r dot r cap, that is the first part, guys, first part. I'm going to come, what are these, guys? Okay, second part, second part. Then, guys, what, this is alpha cross r, that is what, guys, your third part. And plus, guys, what, this 2 omega cross, guys, what, this r dot theta cap, guys. Okay, this what we are having, we are going to call this, guys, what, v rotational. Okay, v rotational, I'm going to write this, guys. Okay, v rotational. Okay, v rotational, this is, guys, what, your fourth part. Okay, this is your fourth part. So guys, these are the four parts of what, guys, acceleration we are going to see in the reality, guys. Okay, what are these, guys? Try to understand. See, guys, these two are the radial vector, radial direction acceleration, guys, and these two are what, guys, tangential direction or the transverse direction, guys, acceleration. Okay guys, this one, this one is basically, guys, what we have already seen, this thing minus omega square r cap, that is what, guys, that is the centripetal acceleration. Okay, and this we can write like this way, guys. Okay, this we can write like this way, guys. So actually, guys, this part, okay, is this part is what, guys, it is known as your centripetal acceleration. So guys, when body is moving in a some sort of with it is covering some angle, guys, it is moving on a some circular path or some sort of curve, so that where angle change is continuously happening, guys, so it will need some, guys, what, the acceleration towards the what, towards the inward direction of what, the radial vector. Okay, so that is, guys, what known as what, your centripetal acceleration. Then, guys, this second part. Okay, this is what basically, guys, that it is what, it is the rate of change of velocity which is increasing or decreasing the length of position vector. Basically, guys, how the position vector length is changing or not changing, that is dependent on some radial velocity component, and that velocity component is how it is changing, like how with what it is increasing or decreasing, is going to be, guys, what is going to be decided by what, this component. Okay, how this length is going to change, guys. Okay, now coming to what, guys, this component, this is, guys, what, this is, this is, guys, what, this is known as what, your tangential acceleration. This also we have discussed in our starting of the lectures. Okay guys, so if you see, guys, this is known as what, guys, this is known as, let me put it with some other color. Should I put it, guys? Okay, let me put it with a different color, guys. So this is, guys, known as what, your tangential acceleration. Okay, it is known as what guys? Tangential acceleration. So when the particle is guys rotating and it is covering some angle, so with what rate guys, that rate of covering of angle is changing is known as what guys? Your tangential acceleration. And this is guys what? Your third part. Now guys, this last segment guys, okay, this also we can call as guys what? Euler acceleration also we can call it. Okay, if we want to call it guys, we can call this also Euler acceleration. Okay, now guys, coming to the last segment guys, that is what? This is guys known as what? This is known as your Coriolis acceleration. Okay, Coriolis acceleration. And guys, what is this v rotational I'm going to talk about? Don't worry, okay, just I have written that. Don't worry, what is that? I'm going to talk about everything in and out. Okay, so guys, let me write down that also. This is guys what? This is your Coriolis acceleration. Okay, Coriolis acceleration. So guys, this is your Coriolis acceleration. Okay, now guys, you are interested in you might be interested guys, sir, what is this v rotational? Okay, what is this v rotational? Okay, what is this v rotational? What does it mean guys? Okay, so let's try to understand guys. Here if you see guys, this is what? R dot. Okay, this is what R dot means. With what rate the magnitude of length of what the position vector is going to change, that is guys known as what? Your R dot vector. I hope you remember this thing guys. Okay, that with what rate the position vector length is going to guys change, like it is going to increase or decrease, that is going to be defined by what guys? R dot. Is this okay? So guys, this R dot, if we want to find out, we have to sit in a some certain type of frame, then only guys what we can see this velocity guys. Okay, this velocity in which kind of frame? Try to understand guys. Suppose guys, try to understand. Suppose guys, a particle is guys moving on this curve. Okay, is moving on this curve, and guys here we as an observer guys, let's say right now particle was here. Okay, particle was here guys. Okay, and yes, just let me put it this way. Okay, so guys, if you see, listen this guys very carefully, because then only you will understand this logic. Guys, here if you see, my eyes are watching right now what? This particle here. Okay, so guys, this is the position vector. Now guys, what is happening? It will go like this. Okay, and suppose it reaches here guys. Okay, so what I want guys, I want that I should not be able to see what? That where the particle has gone guys. If you see, 1 minute guys, how should I explain this? So guys, if you see, if I rotate my frame, okay, if I rotate my frame guys, if I rotate my frame like this way guys, try to understand. Okay, and let's say guys, the particle has gone somewhere here. Okay, particle has gone somewhere here guys. So earlier also guys, my eyes, when I was watching from here guys, I was seeing that the particle is in front of me. And guys, when the particle is here, my eyes will be what guys? Again here only, and I will be watching guys what? It is in front of me only. What is happening guys? It is going away from me. Okay, earlier it was at this distance guys, now it has what? Gone in this distance. Okay, then guys later my eyes will change the position, and guys I'll see that somewhere here it has gone. Okay, so guys, if you see, my eyes is rotating. Okay, my eye is rotating, and it is rotating with the same angular speed, okay, as this particle is rotating. Okay, means how it is covering its angle guys in the space with respect to origin, with that rate only guys, my eyes are also what guys? Rotating. So that what I am seeing, I am just seeing guys with what rate it is going what? Farther from me. Okay, means basically guys what? R dot. Okay, so this R dot guys, if you want to find out, this R dot is what guys? It is basically the velocity that we as a frame seeing when we are rotating ourselves along with the what? Particle, so that we are just only watching that how the particle is going away not this that the how the particle is rotating with respect to us. Okay, basically every time when I am watching, guys, I am seeing that particle is in front of me only. Why? Because when I was here and I was watching it, particle was here. Okay, and when I changes my eye right now here, I am watching that particle is here. Okay, so my axis, my x-axis, guys, is still what, in front of the particle only. Earlier also, guys, what, my x-axis was what, in front of the particle. Here also, guys, what, my x-axis is what, in front of the particle, guys. It means what, with respect to me, the particle is only either going farther or, guys, coming closer to me. Okay, but not changing its angle or orientation with respect to me, guys. And that is only possible when I am also rotating my eyes with respect to what, guys, my I'm also rotating my eyes, guys, but with the particle movement. Okay, guys, how the particle is moving, I'm also, guys, rotating my what, the, what we can say, the eyes. Okay, so in that case, guys, what velocity we will see, that with what it is coming farther, or with what it is, guys, coming closer, that velocity is known as, guys, what, v rotational. Okay, that velocity is, guys, known as what, your v rotational. So I hope you guys, you understand this component. Okay, so this component, guys, we will need when we will handle the problems of what, Coriolis forces. Okay, but in general, for circular motion problems, guys, this element and this element will get eliminated. Why? Because radius is what, constant, so this will be what, guys, 0. So directly this will be 0, guys, and v rotational will be also what, guys, 0. Why? Because the length of the radius is not changing, so r dot is also what, guys, 0, so this will be also what, 0. So in that case, we will again come back to what, guys, this and this component only, which is what, centripetal acceleration and the tangential acceleration. Okay, but if any general motion is happening, guys, then this will be what, our common acceleration. I hope this is clear, guys. Okay, I hope this is clear. So, guys, we have discussed that what is the velocity vector of a particle when it is moving on a general curve. Okay, guys, that we have discussed. And then, guys, we have discussed what would be the acceleration of the particle at a time when it is moving on a general curve, guys. And we have discussed, sorry, guys, we have discussed all those discussion here also, guys. Okay, and then, guys, what, after that, I have discussed what is this v rotational, and I have discussed what, guys, what is actually the rotating frame. I have tried to explain that. Okay, so if you got it, that's very very good, guys. If you did not get it, not to worry, guys. We are just try to listen, see the lecture again, guys. Okay, you will get the idea. And, guys, after that, in the next lecture, I'm going to cover what, this fictitious force part. Okay, basically the pseudo force and everything. Okay, so that I'm going to cover in the next lecture. So, guys, for today, I think that would be it. So, guys, I'm just putting the heading so that we will continue from here, guys. Fictitious forces, fictitious forces, that is what, guys, that is pseudo force, sorry, centrifugal force, centrifugal force, Euler force, and and what was, guys, Coriolis force. Okay, Coriolis force. Okay, Coriolis force. Okay, guys, so all these three, guys, we are going to cover in the next lecture. Okay, guys, so thank you so much for today.